Where did containers come from? Not these shipping containers. I'm talking about containerization tools. Well, it's actually one of the great mysteries of the planet, and that is because nobody really knows. Well, the origins aren't clear, but we can trace back the roots to chroot or chroot. Chroot allowed changing the root directory of a process. This helped isolate a process so that it won't disturb other processes. Now, this marked the beginning of containers. However, the real breakthrough came with Linux containers in 2008, which introduced C groups and namespaces. You can read more about C groups and namespaces from this Stack Overflow website. I'll leave the link in the description down below. Anyways, Docker was also initially built on these Linux containers or LXC. But since these containers came with built-in features, it made them unnecessarily heavy. Hence, Docker created their own container runtime called as libcontainer in 2014. This significantly boosted Docker's performance, giving way to its widespread adoption within the developer community. Now, in 2025, Docker holds the highest market share with over 63,000 developers using it. Even if you enter the field of DevOps, it is always recommended to start with Docker and Kubernetes. That's how popular and essential Docker is in the world of DevOps. Now, if you're also someone looking to enter the DevOps field with Docker, then you've come to the right place. Now, I'm going to assume that you've never worked with Docker before, and as such, we'll go through Docker file, images, containers, volumes, basically everything you need to know to get started with Docker. Following Richard Branson's quote, the best way of learning about anything is by doing. The course will be completely hands-on, so I recommend you follow along with your own systems to get the maximum out of this video. But before that, you need to be aware of certain key terms. Don't jump right away. First, understand the theory, then we'll implement it together. Docker, in practical terms, is a way to package your application into a container so that it can run anywhere, regardless of the underlying system. For example, let's say my PC has Node.js version 20, but someone else is using Node.js version 17. Now, some features that I'm using in my application might not work on their system because of the version conflict. Now, this is a very common issue, especially between developers and testers. Now, what Docker does is, it packs up this application and keeps track of all the dependencies and versions that I'm including in my application. Hence, when someone else runs this container, it works exactly the same way on their machine, regardless of whichever version of Node.js or any other software they have on their systems. Now, to understand how Docker does what it does, you need to understand two concepts: Docker image and container. An image is like a miniature model of a house. In technical terms, a Docker image is a template with all the necessary files required to create a container. Now, if you use this model as a reference and build an actual house, it is called as a container. Or in other words, a container is a running instance of an image. Now, even to design a miniature model or this image, we need to have a blueprint. And that blueprint, which contains a set of instructions to construct a house or an image, is called as a Docker file. Or in technical terms, a Docker file is a text-based script containing a set of instructions that define how to build a Docker image. So to sum up, the blueprint is a Docker file which contains the instructions to construct an image. The Docker image is the miniature house model or a pre-built structure which can be used as a reference to build other houses. And the Docker containers are the real houses built from these miniature models or from the Docker images. Now, these three concepts are primarily used to solve the problem of, but it works on my machine. The developer who builds the software defines the environment using a Docker file. From there, any developer can use the Docker file to recreate the environment, which is stored as an immutable snapshot called as an image. To run the software, developers can pull the image and spin up a container. So in short, a single image can be used repeatedly across multiple processes and locations. Docker's ability to spin up containers across different systems is its superpower. But the superpower comes with a price. Docker containers are stateless, meaning the data stored within a Docker container is temporary, and as soon as the container is shut down, all the data disappears. To keep this data from disappearing, we have Docker volumes. They are used to persist data generated by containers. You can create volumes separately and use them as a centralized storage option so that multiple containers can access them. In practice, microservice architecture is preferred, meaning one process per container. That is, say if we have a container with a Node application running in it, we can create another container with a SQL database connection, and the data from this SQL container can be stored in Docker volumes, which can be accessed by all the other containers. The last concept you should be aware of before we begin the hands-on is Docker Compose. We talked about microservices, right? Where one process per container. These containers run in parallel, and they do that with the help of Docker Compose. So what Docker Compose does is, so instead of manually running multiple Docker run commands for each individual container, Docker Compose allows you to run all the containers using a single YAML file. That pretty much sums up all the concepts you need to know as a beginner. Now let's see them in action. But here's a little advice. Try documenting everything because it's a great way to lodge things into your brain. If you don't want to note everything down, just note down the keywords or just type them on your phone or your laptop. This will help with your memory retention. Plus, when you look back at it, it'll bring back whatever you have learned. So, let's get started. So now let's start with the hands-on part. So for this hands-on part, what we're going to essentially do is we're just going to host a Node.js application, a simple Node.js application. We're just going to put a server there and we're going to host that server on Docker containers. So for that, initially the prerequisite is that you install Docker. And now if you don't know how to install Docker, don't worry. I have installed it myself and I went through all the steps and took screenshots of it and I put it on my GitHub page. So you can just go to my GitHub and find the files there. Also, there were some issues while configuring Docker that I faced and while making this video that I faced. And whenever I encountered a problem, I kept on continuously taking screenshots of it so that if you encounter the same problem, you can again find the particular document in GitHub. From there, just pick up the document and resolve whatever queries that you have. With that said, let's get started with the video. So first of all, let's create our node project. Let's call this Docker node. Let me open that. Okay. I'll open my VS Code here. There you go. So now the first thing that we're going to do right here is we're going to configure node in this particular VS Code. So now that everything's set up, let me open a terminal. If you don't know how to open a terminal, it's right here. File, terminal, new terminal. Okay. So obviously let's start our node application with npm init y. Let it get installed. Yes. Okay. I'm going to install Express here. If you have any other framework in your mind that you prefer to work with, you can go with that. But I usually go with Express and most beginners do that. So npm install Express, let it get installed. Now, once we set up our node files, we'll check for our Docker files. Docker I've already installed in my system, but just to check if it's there or not, just check for Docker is this version. And it's right there, meaning our Docker is fine and working. Now what we're going to do, come over here and create an index.js file. Now let's use the boilerplate code. Node Express, and we've got everything we need. Instead, I'm just gonna change this to Docker, and we need a whale. Yeah, there it is. I used it the last time, that's why the whale is here. Or you can just search for whale, and you'll find it. So this is completely unnecessary. You can just not do it, but I just like doing it. So now that we're done with this is the most basic steps that anybody can do. Now comes the important part where you need to configure the Docker files. So now what we're going to do, create a Docker file. Look at the spelling, it's very important. These capital rest, everything is smaller case and everything is kept together. There's no space in Docker and file. Now we create our Docker file. Okay. So the first thing that we're going to do in a Docker file is we're going to add from, and okay, it's here. From, we're going to give a base image. Now a base image that we're going to give here will be node 18. And if you hover over it and click on control and then click with your mouse, you will be redirected to this Docker Hub's official website. And here you can see this image of node, which is created in the official Docker Hub. Now, image essentially is a, like we discussed before, a miniature model of your Node.js itself. Now, again, say even if I host this on Docker Hub, and then one of my friends pulls that image onto his PC. Now, say Node is not installed in his PC, my application is still going to work on his PC because of this image that Docker Hub is providing. Now, here we're using Node.js 18. Now, if you go into Chrome, um, if you go into Chrome and you check for the Node latest version, now you can see that the latest version of Node is version 22. Yet the version that we are using is Node 18. Why? The reason why we're doing that is because Node 18 was released in 2022. So that version is more stable. And whenever we're building such images, it's always recommended to use the stablest, I don't think that's a word, but the most stable version of any particular software that you're using. So even for Node, we're going with Node 18 because it is a really stable version. Now, the next thing that we need to put is the working directory. Now, this is going to set the working directory for any subsequent add copy command. What they're trying to say is if I set this working directory, and if I set a working directory as, say, app. Now notice the name of this particular folder is actually docker-node. But here I've set the working directory as app. Now this folder is not yet created, but in this Docker file, we're going to add a couple more commands, and all of those commands, the copying command and everything, will be saved in this particular directory. So if some person pulls this particular image of mine from Docker Hub, then the name of their working directory will be app. Like this name will become app, or you can just put the same name. It doesn't really matter. It's totally up to you. Now, the next line is we're going to copy. Just observe this clearly what I'm writing: package star JSON and the current where it's going to be copied. This is what we need to copy, and the space, this is where we need to copy. ./ is the current directory, and package star means because we have two package files. Here one is package.json, the other one is package-log.json. So we're essentially telling the Docker file that any particular file which starts with package and ends with .json needs to be copied and pasted in the root directory. Why are we doing this? This is a concept called as caching. Now, caching we essentially do, I'll ask you to do one thing. Go to your Google browser and clear out the cache, clear out the cookies, and clear out your browsing history, browsing data as well. Now, if you try to open your Chrome browser, it's going to take longer to reload. It won't be like 1-2 minute of delay. It will be just like a very minute millisecond delay, but it will be there. You'll notice that. That is the difference cache brings. What cache does is whatever wallpaper you're using or whatever bookmarks you have kept, it keeps all of it preloaded in the server nearest to you, so that every single time you're opening the website, the data is not loaded from the primary server. Instead, it's loaded from the server that is closest to you. That's called as caching. Similarly, here also, instead of going around and installing the whole npm package, we're going to keep the dependencies. The package.log and package.json essentially contains our dependencies. So we're just going to tell Docker that all of these dependencies need to be cached so that they don't need to be downloaded over and over again. Now, the next thing we're going to provide is we're going to tell what we need to download. So the next thing that we need to do is we need to tell that some commands, some files need to be installed, such as our node modules ka file. This one we don't need to cache because look at this. We cannot cache that. It's a lot of files are in there. So we don't really need to cache that. We'll tell Docker file to directly install that. Now the next thing that we need to do is we're going to copy another set of folders too. Now you may ask, we have already copied. Why are we copying again? Look at what we're copying here. We're copying the package.json here. Now, other than the package.json also, there is another file here, index.js. And this is a very small project. That's why we only have one index.js. But imagine if this was a React file. There would be a lot of different files, especially if you configure routes, then there'll be an about page, a home page. All of those files will also be there. Those files, which are already in the root directory, will in this files root directory will be copied into the other root directory when the other person installs it. Are you getting? Like if in my PC, this is my root directory, this file is here, another person copies it, this file will go to their root directory as well. That is what this particular line is doing. Now the next thing that we need to do is we need to expose a port.
Now notice, now keep in mind that this port is not this port. Your server is getting hosted, your container, your Docker container is getting hosted on port 3000, not your local server. So that is when we run this particular file, and if I go to localhost 3000, port number 3000 in my PC, that port, in that port, this particular website will not be hosted. This port is only to host the container. Are you getting? The container is hosted on port 3000, not the server. Now the last line that we have, it will be the command, the default executable for this executing container. After providing everything, we're just going to give the command on how to run our application. So the default file that needs to be run will be the index.js, and the command that will be used for running our index.js will be node. Have you ever tried running this code with the help of terminal, your command terminal? At that point, you always write node index.js or node server.js. So that's what we're telling in this particular command line. And with that, we have covered our Docker file. Another thing we need is a Docker ignore file, which starts with the period, then Docker ignore. This is very similar to your git ignore file, which in which you provide the specifics of which file should you not include. So we already discussed about node modules. You're not coming with us, so we're leaving it behind. And we also don't need our Docker file, and we also don't need our Docker ignore file. That also doesn't need to be mounted. So these are the three files we do not need. Now, other than that, we are all set with our container. Now, all we need to do is build the image from this container and run this container. So now let's build the Docker image. Now that our Docker image is all set, we need to build the image. But before doing that, make sure that you have started your Docker desktop, or you have installed Docker desktop on your PC. I'm assuming you have done that. If you haven't, GitHub is there, go download it from there. And then open the desktop version first, because if you do not start the Docker desktop version first, your VS Code will not build the Docker image. So it'll start the Docker engine for you. Yeah, it's written here only. The Docker engine is the underlying system which runs the container. So we need to start the Docker engine. This is your Docker engine, the Docker desktop. So I've started the Docker engine. Now let's build our image, Docker build. So I'm going to call this application my node app. You're free to call it whatever you like. And I'm just going to put a period over here. Now let's start it. Now it's building our Docker image for us. So let's wait until the whole image is built. Now, when the image is building, it actually goes in form of layers. So all of these files are actually layers. This is layer 1, layer 2, layer 3. That's actually how Docker works, layer by layer. So our image is successfully built. Now we can run the container. So let's run it. Docker run, pay attention. Now I told you the port that we were using here. This was Docker's containers port, not the port in which you will start your website. So we're going to start it on port 4000. We're going to map the Docker container on port 4000, and the port of the container is 3000, which we're going to mention here. Then we'll just provide the name of our application, which is my node app, and then we'll hit enter. Now, although it's showing example app listening on port 3000, let me show you. If I go into, say, localhost, that's, okay, this is 4000. Let's go to 3000. And you'll see that this site cannot be reached. However, if I go into port 4000, hello Docker. That's what I told you. Port 3000 is where the container is hosted, and port 4000 is where your website is hosted on this particular local machine. And this particular 4000 can be changed anytime. That's why in this command, you can even change it to 5000 or 6000 or anything you wanted to. But this one is going to remain the same. Whichever containers is this container has its container host, like this particular container is hosted on port 3000. If I create another container and host it on 2000 and then ask to be hosted it on this port 4000, so right now I'm asking Docker to host the container with port 3000 on my port 4000. If there was another container with port 2000 and if I specify 2000 here, then the container with port 2000 will be hosted on the port 4000. I know it got a little messed up, but I would recommend you trying it on your own, then it will be more clear to you. So now that our application is running, and now that our container is running, now the main point of Docker is not to host our website. क्योंकि वो तो हम we could have done with Node.js also. Node.js also I can host like this, right? So this was not the point of Docker. The point of Docker was that this particular image of mine can be hosted on Docker Hub, and then any other person can pull that image and run the same window with everything like this on their system as well. How do we do that? So for that, go into Docker Hub. After you reach Docker Hub's main page, sign in or sign up if you haven't already. Because if you have already installed the application, you would have signed in already. So do that first. Then go into repositories. And as you can see, there is no repository right here. So create one. Create a repository, give it any name. You can give it any name. I'm just gonna keep the same name, my node app. Create it. Make sure it's public. Now that our repository is created, keep this in mind because this will be very, very crucial in our Docker, in the following commands that we're going to use. And if you come into Docker desktop also, you can see that this one is started and it's already given a name also in the Docker container. So let's go back to VS Code. Now, I'm going to open another terminal. So first what you need to do is log in into Docker if it hasn't already, because without logging into Docker when you put Docker login, what it's going to do is it's going to essentially open up Docker Hub in your Chrome browser and verify your credentials. Since I already did it first, that's why it didn't prompt the window to open up again. And the reason why we're doing this is because it's going to sync with your Docker Chrome browser wala account. So if you don't do it, then you cannot push into that repository. So before pushing the particular image into the container, we have to tag the image. Now, right, in this particular case, we only have one image created, but usually there can be multiple images and it's recommended to only have one process per container. So meaning like for hosting my server, this index.js, I can call it as server.js and keep this as my website, like the hosting endpoint. And I can create another page with my HTML and CSS page and call that as my index.html file. And I will need to host that on a separate container. Now, if I add, say, SQL database connectivity in the middle, I need to add another file and that will be hosted on another container number 3. So that's why we need to tag whichever image we're going to use. So we're going to tag that particular image and this / the name of your repository. This line though you understood, this is the name of this Docker image. I created the Docker image with this name. This particular line is the name of the repository which you can find here, which I told you. Keep this in mind, the name of the repository that you created. This thing is inputted here. Now let's put enter. Now that image has been tagged like that. It's more like selecting, like if say if I go into my folder, if you tag something, it's like this is tagged. This is how it works in Docker, selecting that particular file. So we've tagged this file, we've tagged the image file. Now we're gonna push it into my GitHub repository. Okay. So let's push it there, and now it's getting pushed. So let's wait for that to happen. Essentially what we're doing, we're sending all of this, whatever code we have written, to the Docker Hub. And now that's going to, and remember how we kept it as public. So any person who's using Docker can simply go over to Docker Hub's website and just download that image. And downloading that image is called as pulling that image in terms of Docker. Since we're talking in Docker terms, it's called as pulling the image and not downloading the image. So uploading is called as pushing and downloading is called as pulling in Docker terms. So since we're working on Docker, we'll speak in Docker terms. Okay, it's taking a lot of time to get pushed, but yeah, fine. Let's wait for it. Yes, so it has been pushed. Now keep in mind that the tag I've used is called as latest. Now this is more like the versions of the particular file. So if I'm going to push it again, like in Git you push, and every single time, if you've worked with GitHub, Docker Hub is going to be very easy for you, because in Git also you again do push and pull, which is the same as uploading, downloading. Same we are doing here also in Docker Hub, also pushing, pulling. So every single time you make changes in your GitHub repository, you have to change the versions, version 1.2, version 1.2. You change the commits, right? So same, just like that, here we're using tags. So here we have latest tag, and then if I push again, I'll be like latest 1, latest 2, in such a way. So if you go to your Docker web, and right now it's not here. So if I reload this page, the latest one, which we just pushed, is right here. So that's how you push your image into Docker. So by this point, we have clarified, we had 3 most important things to learn in this session. First one was how to create Docker. Before that, I'm not going to count the installation and all, that's not included. So how to customize, or how to create, how to work with Docker, we covered that aspect. How to push in, or how to build an image in Docker was part 1. How to push that image into Docker was part 2. Another part 3 is how to pull that image. So how to download this particular image which you have pushed. Any person can download this. So now let's try doing that. I'm just going to close this VS Code completely. I'm going to close this file explorer also. I'm going to create a new folder called as Docker. What do you call this? Docker pull, probably. The name has nothing to do with it. It's just for my thinking and yours, so that you will know, okay, this is for pulling. This is where we will be pulling that image. Now this folder has nothing. I'm just going to open my VS Code here. I'll close that. My VS Code is open. Again, there is nothing in this particular folder. So now let's open our terminal. I'm using the Windows keyboard shortcut actually. But you can just manually do that from here again. It's right there. I'm just gonna write the command docker. Again, you need to make sure that it's logged in, but since I already logged in my previous VS Code, I'm assuming it's there. Let me just try it again. Yeah, it's already logged in. Okay, so now I'm gonna pull the image, docker pull. Again, my repository name and the image that I want to be pulled using the default tag latest. Okay, so now that it's pulled, let's check if it's pulled properly. Docker images. Now with this command, we'll see, yes, there it is. My node app, the latest version, which we created 12 minutes ago. We have pulled that image successfully. Now, how to run this file? Container. We're going to use the same command. We're going to use the same command we used to run in our previous VS Code. Docker run p. Okay, 4000 is already active. Let's use port 5000. We're going to use the container 3000. And the name of our image is my node app. So it's listing on port apparently 3000. 4000, it's already working. This is running because of our previous VS Code. This time we listed on port 5000, and there we go. It's working here as well. Now the interesting thing about Docker is there is not a single file in my VS Code, and even if you go into this folder, if I reload this is a folder where our VS Code is running. There is no file. No file is in the system. The file is being completely pulled from Docker Hub and is being running on your PC, but not a single file is here in your VS Code. That is the power of Docker and containerization. So now, in case you want to, like, even when you use repositories on GitHub, when you fork that repository, you get the files. So that is our next topic, which is a additional topic. For Docker, the 3 steps we have cleared: how to create an image, how to push the image, how to pull the image. Now the 4th step is an additional one. That is, if you need the files, how can you copy the files from Docker Hub into your local systems? So for that, let's just create a new container. So now what we're going to do is to find the files which are inside the container. We need to actually first locate the container. Now there can be a lot of containers in Docker Hub. You need to find the container that's yours. So check for the Docker PS so that we can find the ID. There's the ID of our container which we recently created. take that container ID, not that one. This is the initial one that we had, but this is the one that we are running in this particular system. So let's take that. I know now this is harder than GitHub, but it's just one line that you need to write, which is docker cp, write the containers, paste the containers ID, and then app, the directory name that we even specified in working directory, and then the name of the image, which is my node app. Press enter and everything is copied. That's it. There's your file, which you wrote in the other VS Code. That's it. And that's how you copy paste everything. But before I leave you guys, just make sure that you have deleted. Now this is again, you make sure that you have deleted all of these containers because you don't want them running around forever in your PC. So just delete them. And that was it for this video. If you stayed till this point, thank you so much. And don't forget to, and if you like this video or if you found something useful in this video, make sure to hit the like button and subscribe to our YouTube channel to never miss out on any updates from us. Bye bye.